Hi guys, my name is Eian Davis. I'm one of the primary support technicians here at GeoCue, and today we will be going through the second day of our in-person workshop, which will be covering data processing and deliverables. If at any point I go a little too fast, I go a little too slow, I lose you, feel free to stop me. This training is for the people in this room and for those in this video, so I do want to make sure you can keep up with me. For a general breakdown of our content for today, we are going to be going through the entire TrueView data processing workflow. We will then go into post-processing, which includes that strip align tool that we talked about yesterday, cleaning and preparing our data, ground classification, accuracy estimation, deliverables, and we're going to talk about the LP360 Cloud. First things first, about your file pathing. There are a few very important things to keep in mind. One, don't ever use a cloud storage location for your installation or your active project processing. If you're using something like OneDrive or something of that nature, it can lock the files while it's trying to synchronize and prevent you from processing. So you do want to have your data stored locally on your machine if you are actively processing it. Long-term storage is perfectly acceptable to be in the cloud. There's also a 200 character limit for LP360. This is not a limitation of LP360, this is a limitation of Windows. So do keep that in mind. You want to try to keep your paths as short and sweet as you possibly can. I also strongly recommend that you avoid using any special characters or spaces in your file path. Spaces and special characters can cause issues through processing, so do keep that in mind. We want to stick to numbers, letters, underscores, and dashes. Additionally, if you are using a portable storage device or network storage over a long time, you do want to make sure you are checking the performance of those, as it can degrade over time. Mechanical hard drives do have a poor performance during data processing, but they are perfectly acceptable for your long-term storage. Just keep that in mind. We strongly recommend that you get a fast SSD for optimized data processing if you do not already have one. Now, to get a general breakdown of our workflow, we do have this nice little graph here that takes us through data collection all the way to our product deliverables. So of course, yesterday we talked about field checking our data, and then we went into the TrueView post-processing steps. That's where we created those flight lines, that's where we generated our point cloud, did our trajectory, performed strip alignment to refine that point cloud, and then we did our accuracy estimation. Now, the cleaning and preparing and the ground classification into accuracy estimation can kind of be interchangeable. You do not have to stick to this strict format. For those three steps. They depend on your specific needs and your particular terrain. Now, for example, if you do have vertical objects near your targets, such as grass, a vehicle, maybe people standing next to it, something like that that can be collected in your point cloud, you would want to do your ground classification first before moving into accuracy estimation. If objects such as these are not detected around your targets, you can do your accuracy estimation before moving into the ground classification. So if you needed to perform a debias or anything like that, you can do that before performing that classification. Once you have verified that your point cloud is classified the way you want, that it is accurate to your specific standards, you can then move into your product generation, which can be the last file itself. It could be a LandXML, a DEM, contours, and much, much more. Yes. Yesterday we also talked about our cycle archive. Yesterday we went through creating a archive location. For the sake of repetition, I will be doing that again today, but you're more than welcome to skip that step if you would like. But this serves as a functional data backup, because not only is it going to utilize RoboCopy, which does an integrity check of your data before and after you transfer it, it's also going to zip that file so it will take up less storage space and help prevent against any corruption later on. For our import wizard, so yesterday we did see where we could include ancillary files, which are entirely optional. They do not impact our data. We looked at how we can include those base stations. We checked out our project coordinate system, also known as a SRS or CRS. And you have the ability to import multiple flights at the same time. Again, we will be covering all that same material today like we did yesterday for the sake of repetition and ensuring all of our data is stored together. As we discussed yesterday, there are 3 parameters for creating your flight lines. That's going to be your minimum length, your turn radius, and your max deviation. Now, the minimum length is going to be the shortest desired length of your shortest flight line. This can be measured in LP360 before running this tool. The turn radius will actually trim away from those detected turns. You can increase to compensate for any wide turns that you may observe during flight. And your maximum deviation means if your flight line deviates up, down, left, or right by the number of units specified, you will see it is chopped into multiple flight lines. So this is observed most often when you are following terrain or something like that, so you will likely want to increase that number for those types of missions. On the second page of this dialog is called Edit Mode. Edit Mode automatically enables your select tool, and it will save all the edits that you perform while this dialog is open. Now, to delete lines like we saw yesterday, you can simply select those and then use the keys on your keyboard, delete and enter, to remove those pretty quickly. And then you can also turn on your trajectory points associated with those flight lines and manually create them to your liking. Our next step, we used sensor processing yesterday. This bundles both the trajectory processing and geocoding into a single dialog and allows you to configure settings for multiple cycles at one time and submit them all off. You do need the unlimited license to be able to do multi-cycle processing in this function. So do keep that in mind. But if you only have a single flight, you are also more than welcome to use these separate tools. They will all function the same. You will just have to do one at a time if you use the separated out tools. To talk about our trajectory processing a little bit, there are some differences out there for some of the payloads, so they can either utilize the Planix processor, the CHC nav, or the TrueNav, depending on your type of payload, and we do have reference to all of the trajectory report review guides that we have available online. Now, for your payloads, you have the option of running locally or through the cloud, depending on the configuration of your hardware. Okay, so whenever you purchase a TrueView unit, this information is provided to you at time of purchase and through an email. Additionally, we have some paid services that can work as an alternative or a backup for your single base processing. So if, for instance, your single base got corrupted, or if maybe it did not record for the entire duration, something like that, you can use either SmartBase or PPRTX. Again, these are paid services. They do require LP360 points, which can be purchased through the portal at any time. The SmartBase does work off of the CORS network, so do keep that in mind. If you're in a very rural area that does not have a CORS network very close by, you might want to use PPRTX instead of SmartBase to ensure you have coverage. Now, for single base processing, it is critical that the frame that was used to collect your base station is the frame that is used for your project and it matches the units. If this is not met, you may notice that your data appears in a different location, or it may appear that the height is off, things like this. So do be sure you check those. Again, we do have these links here for the different types of reports that can be reviewed. And today we will be going through the Planix report. Into geocoding, there are a few parameters here that we talked about yesterday. So first off is clip angle. We typically recommend about 40 degrees for most TrueView units. However, there are some exceptions depending on the scanner, such as the 540. Because of the single camera, it can only colorize about 70 degrees below nadir. So we would typically recommend doing maybe 35 degrees here. Even though you can increase that to compensate for bad incident angles, it will eventually be unable to colorize those points. So you may end up noticing they're white or something like that. So do keep that in mind and be sure to check the field of view for both your camera and LiDAR on your payload to understand how much you can increase this angle. The clip range is a radial measurement out from any location of the sensor at any one time that can help prevent noise from being geocoded. So for example, during your flight, if you passed by a cloud of bugs or maybe a bird or something that came within a few meters of your drone, you could specify that the minimum distance a point has to be away from your drone. In this case, it looks like 3 meters. It will not geocode anything that is within those 3 meters to the drone at any time during flight. Same with the maximum distance. If you notice there are points well below your surface, you could add a maximum range there. Any points that are detected farther away than, in this case, 75 meters from the drone, it will not be geocoded. Okay. TrueTrack helps to compensate for pitch and roll issues, so dynamic issues that may occur during flight. So we do strongly recommend that you always leave that one enabled. Additionally, you do have the option to colorize. If you would like the processing to go a little bit faster, you can turn this off. There is an entire separate tool for colorization. Same for the update EXIF tags, even though we recommend that you always leave this turned on. If, for example, the photos are not of importance to you, you can disable that and let the geocoding go a little faster. Moving into our post-processing steps, so this is where we help to start refining our point cloud, and that's going to be done through what's called strip align. It does require its own separate licensing. So there is a strip align license. There's also a legacy license called strip adjustment that will also activate this tool. And the entire purpose of this tool is to remove any inconsistencies in the trajectory of your flight. So this can be observed between different flight lines or between different cycles. It can be run on multiple. It is fully automatic with a couple of limited parameters here. So for example, you can disable or enable your EXIF tags and colorization. I recommend having both of these enabled when you are doing these corrections. That way your photos are also corrected for later on use. And then you can specify whether you want to do small misalignment or large misalignment. Small misalignment is intended for errors seen within 10 centimeters or less. The large misalignment is intended for errors observed of 10 centimeters or greater between your flight lines. Now, if you do decide that you would like to run this tool over multiple cycles, they must be contiguous and they must overlap. If these parameters are not met, it will not run. It will fail. Okay. So we did get an example of what this looks like yesterday. We have another one here in front of us. So these colors that you're looking at are actually colorized based on the individual flight lines. Their IDs are called a point source ID. And we can see that it kind of looks like they stack on top of each other. We don't see all these colors mixing. So that's how we know we have some kind of separation, some kind of inconsistency in our trajectory that needs to be resolved. In this second image, we can actually see where they have basically snapped together. So strip align was able to detect and remove that inconsistency and generate us a new point cloud with a much more defined ridge of our building here. Surface precision is another way that you can assess if you need to run this tool. So for example, here we were using the profile view to do that assessment, but the surface precision will allow you to look at the entire point cloud. Now, surface precision is designed to be a robust and automated assessment of precision or noise on smooth surfaces in your point cloud. This can also be defined as the fuzziness of your point cloud. Now, when running this tool, it is defined in the ASPRS definition of surface precision, specifically that it is a measure of a LiDAR system's ability to detect hard, flat surfaces. So if you're in a very rural area with a lot of vegetation, you will notice those areas are always flagged in red. Typically because there's going to be a lot of dynamic movement in our vegetation, so from wind and things like that during collection, so it's always going to have some level of fuzziness to it. But this tool does allow you to enable something called planar surfaces only. That way it will disregard those vegetated areas that it detects. Now, this tool can be activated by a number of licenses. So for example, if you have strip alignment or that legacy strip adjustment tool, you will have access to this one as well. And for our other users, you can also enable it using our business intelligence tool. Business intelligence also includes functionalities such as power line extraction, rail extraction, building extraction, and more. Now basically what this is generating is a raster based on a pass-fail threshold that you can specify. We do have several defaults available, but there is also a customized option, and we will look at that a little later today. In addition to assessing if you need to run strip alignment or not, you can also use the same tool to assess the continuity of your ground surface after you have performed classification. So it can help you identify any areas where low noise or something like that may have been included in the ground surface. So we do have a few settings here. I'm not really going to dive into those, but I am going to talk about the results we're seeing, because do keep in mind you will get a copy of this PowerPoint at the end of our workshop, so you can always come back and use these settings if you would like. Now, what we're looking at here is before strip alignment was run and after. So right here, we're looking at a highway or some kind of road, and we can see there's a lot of red indicated along these outer edges. Now, it looks like we used a threshold of 2 centimeters, I believe. So any surfaces that were detected to have a fuzziness greater than 2 centimeters were either colorized in yellow, and then if they're twice that, they're colorized in red. So that's how we know those areas are not very aligned, they're not very refined, right? In our second image over here, this is after strip alignment has been run. You can see that it really cleaned up those areas. They're now all falling within that threshold that we gave it, which was that 2 centimeters. So that's what we wanted to see. We're going to have a lot more refined and precise point cloud. But something else to keep in mind is up here, if you look in the top left-hand corner of this image, we have red in both of these. This is likely some kind of vegetated area, and again, that's almost always going to look fuzzy to our algorithm because there is dynamic movement where there is vegetation. Okay. We do also have a link down here at the bottom that you could review at any time to modify these settings to your own needs if you would not like to use the ones listed here in future assessments. Now, cleaning and preparing our point cloud includes removing noise and other such objects from our point cloud, and this is done through what's called a point cloud task. Now, a point cloud task originally used to be activated on the table of contents located at the bottom. It has now been moved to a very user-friendly ribbon for execution, which is what you were seeing down here. Opening up the PCT manager allows you to see not only the defaults that are already available to you, but allows you to add, remove, import, export, and rename tools that you may already have available. Now, there's 2 distinct types of tasks. There's going to be your filter, which is either going to classify or change classification of your points. So that's going to be what we use later today for our ground classification, but can be seen for others. And then we also have extractor type PCTs. Again, PCT is just the abbreviation for a point cloud task. Now, extractor types can include our power line extraction, rails, and buildings, along with many others. We do have an article here that goes through all the different types of tasks that are available to you, and we're also going to talk about several that we use throughout our training and that are most common for UAV payloads. So the first one here is going to be our smoothing PCT. Okay, smoothing is a way to reduce the noise or fuzziness of your point cloud. Okay, so this is intended for data sets that are very dense and very noisy. So what it's doing is it does not remove any of the points from your point cloud. It actually identifies the mean of the data itself and compresses those points around that mean. So statistically, your data remains in the same location. Now, this also works to preserve above ground features and does a fantastic job for your ground surface. However, if you are somewhere with dense grass, somewhere with dense vegetation, this can have an impact on your ground surface because there's this concept called a dead zone. A dead zone means when your grass is so thick, so dense, when the laser is hitting the top of the grass and penetrating down to the ground, the algorithm is not able to tell the difference between the two, so it may end up compressing them together and shifting your ground. A lot of the time these will be very minor shifts, but that is something to keep in mind if you are in very rural areas or you're working in agriculture fields. Our next PCT we're going to talk about is the one called the low/isolated noise filter. This helps to identify any points that grossly fall above or below our surface. So it could be caused by birds, bugs, reflection off water bodies, reflection off of a tin roof. All these other such objects can cause these anomalies to appear in our data set that we would like to remove. So this is our first step for that, but if you would like a more robust tool, use the outlier classifier. This is actually a tool found on the classification ribbon, and it helps to identify and remove presence of gross outliers from your point cloud. So it's really helpful for like feature extraction, and with this concept we call holes to hell. That is going to be a point that falls well below your surface that may have not been identified by one of our classifiers. And when you go to do your ground classification, it actually creates like this cone shape in your ground surface. So it looks like it just falls off into oblivion. This helps to remove that before you get to your ground classification step. Now we do have a few recommended settings here. Again, I'm not really going to dive through those during our presentation today. I may, get a little more in depth during the exercise itself, but you can always come back and review this at any time. Moving into our ground classification, once our noise has been removed, there is something you do need to understand about your LiDAR data to know how our ground classification is possible, and that is this concept of LiDAR returns. These are essentially echoes of your laser as it is fired out from your sensor. It's going to hit multiple objects along its path until it hits a flat surface it cannot penetrate. Okay, so it is not penetrating through our branches here. You can imagine it kind of like a flashlight. It doesn't hit your first object and stop. It's going to keep shining until it hits something it cannot go through. So that's typically going to be your ground or a rooftop or something like that. So we are able to take this information and restrict our ground classification to the last or single returns so that we can identify only objects that were hit and could not be passed through. Now, this is used in our first PCT here. So these are the defaults that we're talking about today. This is the name of the PCT in there, but the type of task for our create seed surface task is classify by statistics. So it is going to look at your data in a grid format. You're going to specify a certain cell size you would like to use, and it's going to look for the lowest last return and classify that as a ground point. This helps to get you started in that classification process, but if you have any noise, that can very easily be detected in this step. And also, it is important to take into consideration your building size. So if you're somewhere like a neighborhood or something like that with a lot of buildings around the same size, you can imagine this right here as a building. If our cell size is not big enough to kind of reach out over the side of the building, we will end up getting points on top of it. So for example, here we have 1, 2, 3 cells that fall only on top of our building roof. So we have at least 3 points that need to be removed, or it will be included in our ground surface. Okay. Our next step after we get these seeds classified is to perform iterations. Now this is an adaptive tin ground filter type of task. So this is going to take your seed points, that's what you're going to see highlighted in red here, and it's going to look out at a distance, up at an angle, and grab any points that fall in this area, and it's going to classify those as ground. It's then going to repeat that. It's going to look at these new points here, out at a distance, up at an angle, and grab those points. And it will run for however many iterations are specified. Now we do have a few recommendations here on this page about some general settings, but we will work on modifying those a little later. on how to identify what works best for you and your projects based on your terrain. After that's been done, you can move into the ground cleanup process. We do have two different functionalities for this. The first one is going to be the ground cleanup tool. Now this is a fully automatic tool here. You can either do manual classification where you can actually select points that you would like to classify as ground. You can also select to remove any points that may be inaccurate, and then you can also do the assisted ground cleanup. So that means you get to select a cleanup mode. You can run it over just a small area, which I do recommend if you're testing those results, or you can run it over your entire point cloud. Now we do strongly recommend that you start at normal and then increase in those areas with steeper slope, especially if there's any vertical objects, so vegetation, cars, things of that nature, because if you jump straight into our more aggressive functions, they may end up over-classifying. So do start at normal and then work your way up. Now, something that's incredibly helpful if you decide to use the PCT version of this tool is it actually allows you to select new seed points to run this by, and I will be showing that in our exercise later. So if you were working to classify underneath canopy or along ripraps or anything like that, the PCT will be very helpful for you, and again, we will cover that later in our exercise today. After that's done, you can then run the surface precision tool. As I mentioned earlier, it can be used to assess the continuity of your ground, identify anywhere that may be fuzzy, so maybe where there might be some grass included that you need to go clean up, or if there's any noise that's been picked up in your ground surface, this tool will help you identify those areas versus having to sweep through your entire data sets. Into our accuracy estimation, we do have the ability to classify 3D, so X, Y, and Z, using our checkerboard, concentric circle, and accuracy star targets. So as I mentioned yesterday, and I will mention again today, LP360 is able to tell the difference and has a different algorithm for each type of target. So for example, if you have a painted target, so you painted an X on the ground and you marked it, it is only going to calculate the Z for that. Versus if you have a checkerboard, concentric circle, or accuracy star, as long as you have the 3D accuracy license, it will calculate the X, Y, and Z of that surface. Now this can be done by clicking the Auto Find button. This will allow it to populate with all of those calculations of where it identified your targets. You can use the Solve button to perform your debias. This will actually translate or shift your point cloud to better fit to your control points, and it will create an entirely new point cloud for further assessment down the line. You can also modify your settings like we looked at yesterday. You can modify the search radius that is used for your IDW surface method. You can increase the size of your your checkerboards or concentric circles based on the specific target size that you are using. And you can also export your report. Now we do have several or a couple links here about how to configure your control points, because remember, you do need to enter in the type depending on the type you are using. That is very important. If the type is not included, LP360 will treat all of them like the painted targets, and it will only calculate the Z even if you have that 3D accuracy license. So do keep that in mind. You can also debias your LAS and raster using the Affine Transform PCT. So for example, if you had an orthomosaic that you wanted to shift in the X and Y using the same values that your LAS was shifted by here, when that solve dialog is open, you can actually take note of the X and Y shift that it will be applied, and you can enter those in here to translate or shift your raster as well. Now the debias layer, we typically recommend that if you have enough checkpoints to have a subset used to shift your data and a second subset to actually verify those results. So in the first instance, when you're actually moving it, we would call those control points. The ones used to verify that would be referred to as your checkpoints. Now you're typically going to want, at the bare minimum, 12 points to be able to do this. If you have under 12 checkpoints, you're just going to want to run all of them both times to verify those results have been shifted and are accurate to your liking. This brings us into our deliverables. So as I mentioned earlier, there's a lot of different stuff that can be exported from LP360. That includes contours, DEMs, maybe a thinned ground data set that just gives you a smaller LAS file size if you need that, an ortho, maybe the control report, and a lot more things. So one of the most common is going to be our DEM, also referred to as a digital elevation model. Using the input points filter, you are actually able to specify exactly what points you want to be exported and used for this DEM. So for instance, if you're using a ground classified data set, you could use your ground as the only input. If you had buildings, you could also include that there, and much more. Now, when you change your surface method here, there are a few different options. You will actually see that the attributes that are selectable will change. So if you do have information that you're seeking for the different executables, inside of our export wizard, you can go to our LP360 support knowledge base, and we'll be able to find all of those options available to you. But these are the ones that are most common for our DEMs. You do have the ability to enforce break lines as well. For those of us that are working with line work, things of that nature, you can enforce those on your DEMs and your contours when exporting through the export wizard. Now we have two different ortho tools that I'm going to talk about here. The first one is the Agisoft Ortho Mapping Tool. Now this tool functions as a headless version of the Agisoft Metashape software. So this is essentially a plugin for LP360 that will run in the background. You do have the ability to run through the cloud or locally. But it does require separate licensing since this is a plugin of a separate software. Now, for licensing in LP360 to use this tool, you need the Photo with Agisoft, also called the Photogrammetry with Agisoft add-on license type. If you are wanting to run locally, you will also need a Metashape key. If you are running through the cloud, you do not need this key to activate this function. That will be done through the cloud itself. If you are running through the cloud, it also does require points versus having that Metashape key, so it depends on your specific needs. Now this tool helps to improve its efficiency and accuracy of your ortho by utilizing a DEM derived from your LiDAR. Now if you do not provide a DEM, it will generate one for you, but what we would recommend is that you actually perform your ground classification and classify the rooftops of your buildings and use those to generate your own DEM for input. That way it's not trying to piece these photos on top of trees, things like that, which can make it look more of like a swirling effect. So if you're able to give it a really clean DEM, you'll get much better results that way. Now for some of our CAD users, they may experience an issue with what's called a big TIFF format if they have a very large data set that they're working with, but we do have a workflow dedicated to improving that so you can take it into your CAD software later on. Do keep in mind that photogrammetry is a computationally intense task. Do not run this on Ultrabooks or tablets or it will crash your machine. Okay? You do want it on a robust computer for processing. So our second option for ortho mapping is going to be the regular ortho mapping tool. This is included with the photo license and the Cloud Photo 3000 and a legacy one referred to as the full photo. Okay, this will enable this tool. Now this one produces a fast ortho or an RGB map as we call it, because it's actually going to be using the colorization of your points to generate this ortho. So it is not going to be quite as high quality as our Agisoft ortho tool. So do keep that in mind when you're considering what ortho you would like to use in your processing. Our next deliverable we're going to discuss is going to be contours. Again, that can be exported through the export wizard, and you still have that option for enforcing break lines on that output if you so desire. Now with our contours, you do have a few different formats that you can generate it in, different file types. And that can be shape files, DGN, or DXF types. You can also specify your contour interval if you would like it smoothed, and several other settings, including enabling your annotation, if that's of interest to you. Ground thinning is very helpful when generating your contours or other such objects, because it's going to thin your data set by classifying the statistical median of a grid that's been overlain on your data. So for example, this is a cell size of 5 meters. So inside each 5 meter by 5 meter cell, it will classify the statistical median, so 1 point in that cell, and we'll use that later on for either execution of a different task, or you can use it to export your data. Now this is another classify by statistics type of task. And again, it is very helpful if you are trying to manage your file sizes for sharing the data or something like that. So this is entirely optional, but can be very helpful to allow users to have more flexibility with their storage. We do have the ability to generate a LandXML inside of LP360, and in our most recent release, you do have the ability to enforce break lines on this executable as well. Now, we do offer several advanced workflows inside LP360. The 3 I have listed here are just the most common, which is going to be your power line extraction and vegetation encroachment exercise. We do have a rail extraction option, and we have a break lines article that will give you a generalized workflow that you can follow for generating your own break lines. But there is also a 5-part series that's going to dive into the background and context of break lines and how they came about, how we can use them. So if you are someone that likes that more technical understanding, I highly recommend that 5-part series. It is very thorough for this topic. Now, moving into some of our cloud features, because we do offer multiple through the LP360 Cloud. The first one we're going to talk about is just being able to upload and download data. Now, this does require your cloud collaborator license if you would like to store data in the cloud long term, but it is very user-friendly. It allows you to upload data sets either from an open project, as you can see here, that's what I have my option for, or you can upload files from your Windows Explorer. Not only can you upload these directly, you can actually create a new cloud folder at the same time as your import. So if you have, a brand new project you're working on and you're wanting to keep it all nice and organized in your cloud, you can create a new folder for that project, and you can actually rename the cloud layer for when it's uploaded. That way you can give it a strict naming scheme or whatever best suits your needs. Now, when you go to download from the cloud, again, this is entirely possible inside of LP360. You can select those different folders, including the sample data folder. So if anyone would like to download some of our sample data sets, so we have some for a variety of different sensors. We have some for different exercises from our user conference back in October of 2025, and a lot of other things that are available to you that you are more than welcome to download and play around with. Additionally, you have the ability to stream any data that has been uploaded to the cloud. Now, this does give you 2 different options for that functionality. You can either view it in a web-based viewer at LP360 Cloud, so cloud.lp360.com, or you can get a streaming link. So when you go to stream your data, you can click Get Streaming Link. It will give you a unique URL, and you can actually paste that into the Add Data dialog of LP360 for Cloud LAS options, and it will stream that data into your LP360 project. Now, this only requires an Explorer level license. So with every purchase of a LP360 drone license, you do get 5 Explorer level licenses. So you could use this to share data with clients or with colleagues, and they would not interrupt your processing later on. They would not need that additional, more robust license. We also offer an AI ground classifier. If you do not want to go through all the PCT options that we discussed earlier, this is a very user-friendly way to classify your data. It also allows you to do outlier classification and smoothing at the same time without having to run those separate tools. So you can enable those and submit it all off at the same time. Now, this does have a few requirements for that, and I'll be discussing those on the next page. But if you would like some additional information on this task, we do have an entire page dedicated to this, as well as several video type tutorials on this. Now, the requirements for this task is going to be you must have the Auto AI Ground Classification License add-on. This must be assigned to your user inside the LP360 portal because this is a cloud license. All of our cloud licenses are not just associated with the organization, much like the drone license. It is associated with individual users. So you would assign it to your email, you would sign in to LP360 Online inside of LP360 Desktop, and you would be able to access it that way. Additionally, you need to make sure that you are signed in your desktop. If you do not sign in, you will not have access to the licensing and you cannot submit because it's not going to be able to reach the cloud. And then your data also has to be in a specific structure. Your LAS data must be organized in a regular orthogonal grid of tiles, with each individual tile or file being between 250 megabytes and 3 gigabytes in size, and they must not have any overlap. So you do want these to be individual files. If there is some strange overlap of your tiles, you may end up seeing some difficulties in processing. Now, the reason this size is important is it makes it more digestible for the algorithm. So if your file sizes do not fall within this parameter, so if they're smaller than 250 megabytes, it may not classify very well because it doesn't have enough points to really identify what's going on. And if it's greater than 3 gigabytes, the algorithm kind of chokes on it and has a more difficult time classifying it. Now, in LP360, you also have the ability to upload your data to us here at support through our Upload to Support tool. So if you are having some difficulties with your data, you can't figure out what's going on, maybe there's something going on with your project and you need to give us some log files, you can very easily use this tool. Just make sure you're signed into LP360 Cloud in your desktop, and it will submit those files up for us to review and help you troubleshoot. Additionally, if you would like to expedite some of your support needs, we do have 2 different knowledge bases that have extensive knowledge about our different products. So for hardware, you'll go to support.geocu.com. For software, you'll go to support.lp360.com. Now, this does include troubleshooting options for some of our most common error messages, so you could search that error and get some information that way, but it also contains all of our workflow documentation at the support.lp360. In addition to uploading to support, you also have the ability to request a new feature from us at any time using the Request a Feature button. Now, this feature request will go directly to our development team for implementation into the software. So if you are interested in seeing something new, please submit us a request. We are more than happy to accommodate you to the best of our ability. And the more often a request comes in, the higher priority it becomes and the quicker it will get implemented in LP360. Finally, we do have several different training options. So obviously, for those of you that have attended our in-person training, we do offer this every single month as a workshop. We also offer a webinar version of this as well. So if you have difficulty training or traveling, you're more than welcome to register for our webinars. The webinars are fully recorded. You are provided a recording after that, along with the PDFs of our PowerPoints that are also discussed in today's training. The main difference between our in-person and our webinar is going to be a little more quick and to the point about the workflow, where the in-person is going to be a little more hands-on and you're going to get that more personal experience. So it comes down to what works best for you. In addition to these options, we also have some paid training that's available. So that can either be on-site training if you needed to maybe train a large number of your group, or something like that, maybe you had some hardware you were needing some training on, you can purchase time with one of our technicians for that. And we also have a one-on-one web-based training option as well. So if you do have a custom workflow that you're trying to figure out or something of that nature, you may want to go with the one-on-one web-based, and you will also receive a recording from that, and you're able to provide your own data sets for this execution. That way we can really give you a hands-on experience of working with your own data. And with that, that concludes our PowerPoint presentation for today.